I did my research topic on solar roadways. Solar roadways are solar panels on the roadway that can be driven or walked on. Each panel has a microprocessor that can make them intelligent. The roadway as a whole will have LED lighting that can act as lines on the roadway to make its boundaries. They will also be able to apply warning signs on the road to tell drivers to slow down, yield, stop, etc. The roadways will also use energy consumed by the sun and use power heating elements. The heating elements will be able to melt snow and ice by making the temperature of the roadway a little higher than the melting point. The picture on the right is showing the LED lighting being put to use. The lights are forming the bike line, the crosswalk, and the line separating the lanes. The picture on the left is using sensor activity, and the warning sign needed for that road is being shown on the roadway. Solar Roadways Company was developed in Idaho by a husband and wife team, Scott and Julie Broussard. Their plan for this roadway was for the roadway to act as power plants. The energy that 30 panels can put off is 5.28 kilowatts daily. To put that in perspective, 170 panels would power the average size home per day. The future envisioned with solar roadways is that for everyone to convert their vehicles to electric cars and have the solar panels be chargers for the cars. The picture below is showing you the prototype that was laid down in Idaho. Disadvantages is that the safety of the roadway is not known. The texture of the surface can stop a vehicle going 80 miles per hour in the distance that is required. This is according to testing that was performed at university labs, but the federal highway authorities have yet approved. Also, the impact testing was conducted at the Solar Roadways headquarters, which is at the Broussard's home, by 3D models. The DOT did not perform their impact testing to see if the roadway can withstand the constant wear that the vehicles and trucks will apply. The main factor is being the project is not efficient on cost. For a 12 by 12 segment, it will cost $10,000 on average. Depending on the quality of the road, the estimated amount to replace all American main roadways would be $56 trillion. This is 4 times the amount of the nation's debt. Advantages is that the roadway will generate clean energy. By consuming sunlight and giving back power, this means that the home electric bills will not continue to increase. They will remove the need for power plants, which will create clean air environment. Next, the roadways that contains heating elements will melt snow and ice. This means no more paying taxes for snow removal. Also, the roadways will contain corridors on each side. One side will have the electricity needed for such as telephone lines, data lines, internet, and fiber optics, meaning there's no need for telephone poles or wires. So when bad weather or a wreck happens, one will not lose power. The other side of the corridor has a drainage area for the rain and the melted snow to go to. The channel will filter and transfer the water to a treatment facility or just treat it right on spot. This decreases the amount of pollution in our soil, lakes, rivers, and oceans. Last is the safety of our citizens will improve by the LED technology. If an abnormal object falls or walks across the road, there will be a warning sign appear on the roadway before the car to inform the driver to slow down. This top picture is showing Scott going into the corridor to fix the technology. And the bottom picture shows that his deer is crossing the road and the sign needed appeared before the car to warn the driver. In my opinion, I feel that the idea of this project is in for a lot of work, but I fully support the transition of asphalt roads to solar roadways because of its future to improve the safety and the clean energy. The recommendation for the projects that I would say is to find a way to provide cheaper technology, but have the technology still do an appropriate job because the cost of the project is just not economical. Last, I would suggest continue building prototypes to improve the design, but to have the DOT apply impact testing before laying the test trials on the road. The table to the right is comparing the differences in between solar roadways and concrete and asphalt roads.